Dr. Deborah Liczwek is the Director of Educational Outreach for the STRIDE program. Prior to joining STRIDE in 2019, she had a 35-year career in the DuPont Company, with her last 13 years spent as analytical manager for the refinish paint business. She has a BA in chemistry from Illinois Benedictine College and an MS and PhD, also in chemistry, from the University of Illinois. Using interactive activities, Dr. Liczwek and her team work to engage students to help them learn that science is fun and that science and engineering form the building blocks for technology. The activities dovetail with the Red Clay 6th grade curriculum on forces and energy. The structure and content for each activity were developed by the STRIDE staff in coordination with the involved STEM faculty. Each activity takes the form of an experiment following the standard scientific method. The experiments are conducted after school for 6 90-minute sessions that students refer to as a science club. It's offered to all 6th grade students at each school in the district. However, sessions are limited to approximately 24 because of the number of volunteers available. One of the keys to the success of the program is that students work in small groups and receive individualized attention. This allows flexibility in pairing a volunteer's personal style with that of the students so that differences in ability or approach are minimized. The program is fortunate to have, on average, 8 volunteers per session. The quality of the volunteers is outstanding. All volunteers are trained scientists or engineers with industry experience. Most hold PhDs. A science teacher is always present and participates as the teacher feels appropriate. Each session starts with a 2-minute presentation from one of the volunteers in which that person talks about some of the actual work they do and the value of that work. This provides the students some insight into the type of work industrial scientists and engineers pursue and its broader impact. After this job overview, all are given a brief introduction and discussion regarding the principle the activity explores. A multi-page handout provides background and guidance on conducting the day's experiments. Students break into small teams of 3 to 5. Each team is assigned a scientist volunteer. The volunteers engage the students, requiring them to apply the scientific method. The team must first make a hypothesis. They are asked to question the provided information to define the problem. The volunteer helps them think about what they are measuring, how the measurements are made, what errors might arise in the measurements, and how they might overcome the errors. The team must plan and carry out investigations in the form of experiments and data collection. After performing the experiments, the team analyzes the collected data. Analyzing the data requires the use of mathematics and computational thinking. Students always compile a table of data, and in some cases they also plot it. The team then evaluates their analyzed data and draws conclusions. They need to think about what they have measured and articulate their responses. In many cases, they are expected to provide a quantitative description. They must engage in argument from evidence. Finally, the team reviews any failures and how they affect their experimental results as they relate to the hypothesis. Each team reports back to the whole group, describing what they measured and what they learned from the measurements. After the experiments are completed, a short video or discussion provides context for the experiment. Why is this principle important? Where might each of us experience this principle in our everyday lives?